In this module, we are going to discuss indexing and hashing, its basic concept, ordered indices, dense and sparse indices, multi-level indices, secondary indices, B plus tree index file structures, queries on B plus trees, and updates on B plus trees. An index for a file in a database system works in much the same way as the index in the textbook. If we want to learn about a particular topic in the textbook, we can search for the topic in the index at the back of the book, find the pages where it occurs, and then read the pages to find the information for which we are looking. The words in the index are in sorted order, making it easy to find the word we want. Moreover, the index is much smaller than the book, further reducing the effort needed. Indexing mechanism used to speed up the access to desired data. And the search key. What is a search key is? It is an attribute to set of attributes used to look up records in a file. An index file consists of records of the form search key pointer. Index files are typically much smaller than the original file. The two basic kinds of indices are ordered indices and hash indices. Where ordered indices are search keys are stored in sorted order. Hash key indices means search keys are distributed uniformly across buckets using a hash function. The bucket to which a value is assigned is determined by a function called hash function. Here are some index evaluation matrices. They are access types, access time, insertion time, and delete time and space over time. And the first one is access types. The type of access that are supported efficiently. Access types can include finding records with a specified attribute value and finding records whose attributes values fall in a specified range. And access time, the time it takes to find a particular data item or set of item using technique in question. Insertion time, the time it takes to insert a new data item. This value includes the time it takes to find the correct place to insert the new data item, as well as the time it takes to update the index structure. Deletion time, the time it takes to delete a data item. Space overhead means the additional space occupied by an index structure. And here we will discuss about what is ordered indices. In an ordered index, index entries are stored sorted on the search key value. Primary index means in a sequentially ordered file, the index whose search key specifies the sequential order of the file, and it is also called clustering index. And here also we will discuss secondary index, an index whose search key specifies an order different from the sequential order of the file, and here it is called as non-clustering index. Index sequential file means ordered sequential file with a primary index. It represents one of the oldest index schemes used in database systems. So overall, the ordered indices means the index entries are stored sorted on the search key value. And here we will discuss about what are dense and sparse indices. An index entry or index record consists of a search key value and pointers to one or more record with that value as their search key value. There are two types of ordered indices that we can use: dense index and sparse index. So in the category of ordered index, there are two types of indices: dense index and sparse index. Dense index means in a dense index, an index entry appears for every search key value in the file. Here we can see that index record appears for every search key values in the file. In a dense clustering index, the index record contains the search key value and a pointer to the first data with that search key value. The rest of the records with the same search key value would be sorted sequentially after the first record. Because the index is a clustering one, the records are sorted on the same search key. In a dense non-clustering index, the index must store a list of pointers to all records with the same search key value. So previously we have discussed that in an ordered index, there are primary index or clustering index as well as a secondary index or index sequential file or non-clustering index. So the ordered indices are in indices which entries are sorted on a search key value. So inside the ordered indexes, there are two types of indexes, that is clustering index and non-clustering index. And in ordered indices, we can divide the indexes as dense index and sparse index. So in dense index, we have to discuss both clustering index and non-clustering index. In sparse index, there are clustering index and non-clustering index. Our next type of index is sparse index. In a sparse index, an index entry appears only some of the search key values. That is, here we can see that sparse index contains index records for only some search key values. To locate a record with this search key value k, we find the index record with the largest search key value less than k. Search file sequentially start with the record to which the index record points. Sparse indices can be used only if the relation is stored in sorted order of the search key. That is, if the index is a clustering index. As is true in dense indices, each index entry contains a search key value and a pointer to the first data record with that search key value. To locate a record, we find the index entry with the largest search key value that is less than or equal to search key value for which we are looking. We start at the record pointer to be the index entry and follow the pointers in the file until we find the desired index. Compared to the dense indices, here in sparse index, less space and less maintenance overhead for the insertion and deletion, generally slower than dense index for locating records. So these are the difference between the dense and sparse index. The sparse index consumes less space and less maintenance overhead for the insertion and deletion, and also the sparse index is generally slow than dense index. And here is a new term called good trade-off, which means that sparse index with an index entry for every block in file corresponding to least search key value in the block. That is generally known as trade-off. And the next type of indexes are secondary indices. In this sparse indexing, as the table size grows, mapping file size also grows. In the memory, usually these mappings are kept in primary memory so that the address fetch should be faster. And later the actual data is searched from the secondary memory based on the address got from the mapping. The size of the mapping grows, fetching the address itself becomes slower. Hence, the sparse index will not be efficient. In order to overcome this problem, next version of sparse indexing is introduced, that is secondary indexing. So, to overcome that problem, we are introducing a version of sparse indexing, that is in secondary indexing. In this method, another level of indexing is introduced to reduce the mapping size. That means initially a huge range of columns are selected so that the first level of mapping size is small. Then each range is further divided into smaller ranges. first level of mapping is stored in the primary memory so that address fetch is faster. Secondary level of mapping and the actual data are stored in the secondary memory, that is hard disk. In the figure, we can see that the columns are divided into groups of hundreds first. These groups are stored in the primary memory. In the secondary memory, these groups are further divided into subgroups. Actual data records are then sorted in the physical memory. We can notice that the address index in the first level is pointing to the first address in the secondary level, and each secondary index addresses are pointing to the first address in the data block. If we have to search any data in between these values, then it will search this corresponding address from the first and second level respectively. Then it will go to the address in the data block and perform linear search to get the data. For example, if it has to search 111 in the given diagram, example, it will search the maximum of 111 less than or equal to 111 in the first level. It will get 100 at this level. Then in the secondary index level, again it does maximum of 111 less than or equal to 111 and gets 110. Now it goes to data block with address 110 and starts searching each record till it gets 111. This is how a search is done in this method. Inserting, deleting, updating is also done in same manner. Index record points to a bucket that contains pointer to all the actual records of the particular search key. In secondary indices have to be tens, and this is the figure which indicates the secondary indices. Primary and secondary indices. Indices offer substantial benefits when searching for records, but updating the indices imposes overhead on database modification when a file is modified. Every index on the file must be updated. Sequential scan using primary index is efficient, but a sequential scan using a secondary index is expensive. Each record access may fetch a new block from the disk. The block fetch requires about 5 to 10 milliseconds versus about 100 nanoseconds for the memory access. Next type of index is multi-level index. The index records comprise search key values and data pointers. Multi-level index is stored on the disk along with the actual database files. As the size of the database grows, so does the size of the indices. There is an immense need to keep the index records in the main memory so as to speed up the search operations. If the single level index is used, then a large size index cannot be kept in the memory, which leads to multiple disk accesses. Multi-level index, this is the figure which indicates a multi-level index. Multi-level index helps in breaking down the index into several smaller indices in order to make the outermost level so small that it can be saved in a single disk block, which can be easily accommodated anywhere in the memory. If the primary index does not fit in the memory, accesses become expensive. For that, the solution is to treat primary index kept on disk as a sequential file and construct a sparse index on it. That is, outer index is a sparse index of primary index, and inner index the primary index file. If even outer index is too large to fit in the main memory, yet another level of index can be created, and so on. Indices at the level must be updated or in insertion or deletion from the file. This is the figure indicating multi-level index. There is an outer index. From that we will create small inner index which point out the data blocks.